2.5 practice problems. Which of the following has a central atom with less than an octet of electrons? So as I'm presented with all of these, it's hydrogen bonded with somebody else. Hydrogen can never be the central atom because it only has one valence electron, and the central atom is going to be whoever has a higher electronegativity or who can form the most number of bonds. So when I'm looking at everybody in here, I'm looking to see if there are anybody is there that wants less than an octet other than hydrogen. Oxygen has 6 wants 8. Nitrogen has 5 wants 8. Boron is a moron. It only wants 6. Carbon has 4 wants 8. Silicon has 4 wants 8. So boron is going to be my final answer. Which of the following has 2 lone pairs of electrons? So this is the same molecules that we just dealt with in problem 1. And I'm looking for 2 lone pairs. Hydrogen's never going to have a lone pair, so I'm just looking for whoever the central atom is and if they would have a lone pair. So oxygen, their Lewis looks like this. Nitrogen, their Lewis looks like this. Boron looks like this. Carbon looks like this. Silicon looks like this. Oxygen has 2 lone pairs. As a reminder, when 2 electrons are on the same side, it's called a lone pair, and we have 2 of those here. So A is my choice. Which of the following is isometric with CH3, CH2, CHO? So isometric means that I am going to have the same elements within, and I'm going to have to search through here and make sure that that is true. So I'm going to have 3 carbons, 6 hydrogens, and 1 oxygen. If I have anything other than this, then that choice is eliminated. Here I have 4 carbons, no oxygen. Here I have 2 carbons, 2 oxygens. Here I have 3 carbons, 1 oxygen, but I have 8 hydrogens, so that's not going to work. Here I have 3 carbons, 9 hydrogens, and a nitrogen. That's not going to work, leaving me with option choice C, where I have 3 carbons, 1 oxygen, and 6 hydrogens. The electron dot structure, Lewis structure, for which of the following molecules would have 2 unshared pairs of electrons on the central atom? Again, unshared pairs, this is also called a lone pair. We're looking for the central atom to have 2 lone pairs. You can draw the Lewis structure for the central atom to see what's going to happen here. The only one that has 2 lone pairs is going to be sulfur. So that is going to be my choice. Which of the following molecules only contains single bonds? So as I'm looking throughout here, I'm going to see if there's anything that I can very easily eliminate as having more than a single bond. Here I see HCN. I'm going to need a triple bond between carbon and nitrogen, so that's going to be eliminated. Here I have a C2H6. Let me redraw that line. This is looking good. So far C is my answer choice. Anytime that you see oxygen, you can suspect that we're going to have a double bond, but it's not always guaranteed. C6, we're going to end up with a hexagon here. Poorly drawn. My bad. And then we need to distribute all of the hydrogens. Each carbon is only going to get one hydrogen, which means that they're only going to have one bond. So we are going to need to have double bonds here, so this is not going to work. This tells me the order in which that we are bonding. So CH3 means that I have copper bonded with 3 H's. Bonded with carbon bonded with 3 H's. Then I have it bonded with another carbon bonded to an oxygen that's bonded to an oxygen that's bonded to a hydrogen. This oxygen's going to be happy, but this one's going to necessitate a double bond, and this is also going to necessitate a double bond, so that would get rid of that. Here, same thing. So I have carbon, 3 hydrogens, carbon, 2 hydrogens, bonded to a carbon that is bonded to an oxygen that's bonded to an oxygen that's bonded to a carbon with 3 hydrogens. This carbon's good, this oxygen is good, this oxygen is also good. This is actually just in the structure. That third carbon, we're going to have a branch off, and we're going to have it bonded to oxygen, and then that oxygen bonded to the CH3. That's going to necessitate a double bond. This doesn't. As you saw initially, I did make a mistake in this orientation. As you go through this, it does generally go in the order of everything bonding, but we ended up not having enough bonds in enough places, and we didn't have any remedy other than to rearrange. So this is going to be eliminated after I fixed my structure and I had that double bonded oxygen over here. And then again, that C2H6 that I originally drew out is still my only structure with only single bonds. So that is going to be my choice. Lastly, which of the following is an isomer of CH3OCH3? Again, for isomers, I need it to have the exact same formula. So I need 2 carbons, 6 hydrogens, and a single oxygen. This has no oxygen. This has too many carbons, too many hydrogens, and no oxygen. This has too many oxygens. This has too many carbons, too many hydrogens. This has the correct number of carbons, hydrogens, and oxygens. So C is my final choice.